Okay, welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 10 from the June 2024 Pure Mathematics P2 paper from Edexcel. This is the international A-level paper. And this question here is about, looks like sequences and series again, but like a modeling kind of question, worded problem. It says the number of dormice and the number of voles on an island are being monitored. Initially, there are 2,000 dormice on the island. Okay, a model predicts that the number of dormice will increase by 3% each year, so that the number of dormice on the island at the end of each year form a geometric sequence. Find, according to the model, the number of dormice on the island 6 years after monitoring began. Give your answer, to three significant figures. Okay, now, so here we have a typical type of question. Now, if you did this in IGCSE without knowing anything about sequences, you would find this absolutely no problem whatsoever. Like in IGCSE, you would say, okay, it's increasing by 3% each year. So it's like 100% plus 3%. You say that's 103%, which as a multiplying factor, right as a decimal, is 1.03. Okay, so we know that that 2,000 is going to be increased by this at the end of every year. Okay, at the end of every year, and it's going to be done for 6 years, so we put power of 6. So that's at the beginning of the first year. So at the end of the first year, it's going to be 1.03. Okay, times 1. At the end of the first year, beginning of the first year, it will be 2,000, and then at the end of the second year, and so on, you're going to have to increase. So the end of the 6 years. Okay, after 6 years has passed, you're going to have a 6 there. So you'll get the answer as 2,000 times 1.03 to the power of 6, which gives you 2,388.104, 2,388.104. They want it to 3SF. So you put 2,390. That will be your answer for part A. Now, however, that's perfectly fine and that's easy and there's no problem with that question whatsoever. However, I want to try to relate it to geometric sequences. Why? Because as you'll see with other parts of the questions, you kind of need the formulae for geometric sequences for answering these type of questions. Right, so you have to try to relate it to that. And that's where people get messed up. They don't know what number to use, because we know in a geometric sequence, a particular term is given by a times r to the power of n minus 1. And many of you, if you try to use this using a geometric sequence formula, you would say, okay, you would take a as 2,000 and you would take r as 1.03. That's fine. A is 2,000 and r is 1.03. But then you would take n as 6. And you'll take n as 6 and you'll end up to the power of 5 and the answer will be incorrect. And that's where many people slip up in this type of question. So that's where you have to be really very, very careful in such a question. Very careful. Okay. So what it is, the first term is 2,000. This does not mean at the end of the first year. This means the very first term, the beginning, right at the start, initially. That's when monitoring began. At the end of the first year, you're going to be at the second value, which will be this times, it will be 2,000 times 1.03, increase by 3%. And so this represents the end of year 1. Okay, the second term is the end of year 1, right? And the third term is the end of year 2. And the fourth term is the end of year 3. Okay, because this is like the beginning of the first year. This is the end of the first year, the end of the second year, the end of the third year. So the end after 6 years, the end of year 6 is going to be the 7th term. So the n here in this formula is not the same as this power here. This means after 6 years. Okay, the 7th term is after 6 years. So that's where you have to be very careful about this. Okay, so in this case, if we're going to use the formula, our n has to be 7. Okay, there's 7 jumps you have to make, because you start with the first, and that's the beginning of the first year. This is the end of the first year. This is the end of the second year, end of the third year, end of the, and this will be the end of the sixth year. The seventh term will be the end of the sixth year. So if we use the formula UN equals AR to the power of n minus 1, in this case, we're going to look for the seventh term. So it's going to be A, which is 2000, times R, which is the multiplying factor 1.03, the common ratio, what you have to multiply by each time to get to the next term. And here you're going to have 7 minus 1, which gives you 6, which will be exactly the same calculation as this, 2,390. Okay, so this is where you have to take care about the n does not mean the number after how many years, it means the term that you're on. After 6 years, we're on the 7th term, because the first term is like at the beginning. The second term is like the end of the first year. It's like a year has passed, 2 years has passed, 3 years have passed, and this will be 6 years have passed until we get to the 7th term. Okay, so that's something that has to be very crystal clear in your brain when you're answering a question like this. Many people will put here to the power of 6. Some people will put to the power of 5 if they use this formula here, because they'll take n as 6. They will give you the method mark for that, because they know that a lot of people make that mistake, but the answer mark will not be there. Okay, they'll give you some marks for it, for at least getting the multiplying factor and trying to do the correct thing, but you won't get the correct answer mark, because it has to be to the power of 6, not to the power of 5. Okay, I hope that's clear. Okay, now for part B, it says the number of voles on the island is being monitored over the same period of time. So now we're dealing with the voles, we just dealt with the dormice. Given that 4 years after monitoring began, there were 3,690 voles on the island, and 7 years after monitoring began, there were 3,470 voles on the island. The number of voles on the island at the end of each year is modeled as a geometric sequence. Okay, so we've got another geometric sequence. Find the equation of this model in the form n equals a times b to the power of t, where n is the number of voles, t years after monitoring began. T years after monitoring began. A and b are constants. Find the value of a, or give the value of a and the value of b to two significant figures. Okay, so now, again, we have a geometric sequence. And again, we have to be very careful. So t is the years after monitoring began. So this is the number 4 years after monitoring began. So you got the first year, the second year. So this is like the beginning. Okay, the second term of this geometric sequence would be what you get after 1 year. So this is, okay, at the end of year 1, and so on. So the 4 years after monitoring began means the end of year 4. That 4 years after monitoring began, the end of year 4. So that's going to be the 5th term. That's when n equals 5. And if we want to find for the 7 years after monitoring began, okay, so the end of year 7, that's going to be the 8th term, okay, because the first term is the beginning. That's when you can say that's n equals 1. That's like year 0, you could say. It's the end of year 1, end of year 2, and so on. So here we got to be careful. The value of n is going to be these numbers, or these in our, so this, for this case, our n in our formula is going to be 7, is going to be, 5, and the other one is going to be 8. So this is going to be n equals 5, and this is going to be n equals 8. Right, so we have the geometric formula un equals a times r to the power of n minus 1. In this case, we don't have a, we don't have r. We have to find them. A and r, in this case, our a is the a here and r is the b. Okay, so the b here is our r. Okay, and from our formula. Okay, so we want to find basically now the value of a and r from this. So we know that we don't have anything apart from the value of U5 and U8. So U5 is 3,690 and U8 is 3,470. So let's put these in the formula. So U5 would be equal to A, which we don't know, times R, which is our B, okay, to the power of n minus 1, which is 5 minus 1, which is 4. And that we know that that's equal to 3,690. Okay, so that's U5. And U8 will lead us to the equation a times b to the power of 7. Okay, 8, because it's going to be ar to the power of n minus 1. Okay, so let me just write that in clearer steps so everyone understands. So I'll just write it in this form. So you have basically, we know U5 is equal to 3,690. So we can say a times r to the power of 5 minus 1 is equal to 3,690. I'll leave it in this form for now. And this will leave us as a times r to the power of 8 minus 1 equals 3,470. And that leads us to ar to the power of 4 equals 3,690. And ar to the power of 7 equals 3,470. So to solve an equation like this, okay, there's a nice, easy way of doing it. We could use substitution. I could, for example, say a is equal to 3,690 over r to the power of 4. Replace that instead of a here and have an equation and solve it. That's easy, but there's a very nice, easy way of doing it. If we call that equation 1 and equation 2, if I do equation 2 divided by equation 1, okay, the a's cancel out. You've got ar to the power of 7. So you basically have this ar to the power of 7 over ar to the power of 4 is equal to 3470 over 3690. So the a's cancel out. You're left with r cubed is equal to this. Okay, 347 over 369. So therefore r is equal to the cube root of this. So we take this value here. So we have 347 that I've got the cube root of 347. Whoops, sorry, cube root of, sorry. The cube root of 347 divided by 369. And that gives us 0.979717. 0.979717. So they want that to 2SF 0.98. That's r to 0.9. That's r, the value of r. So r stands for, if you see this is n equals a b to the power of t. Okay, so our r is the b. So that's therefore b equals 0.98. And then to find a, we can use any of these formulas. So I can say a r to the power of 4 is equal to 3690. So a is equal to 3690 divided by r to the power of 4, which is 0.979 to the power of 4 in its exact form. So I can take the exact form here. Okay, and I could do 3690 divided by the last answer raised to the power of 4. And that gives me 4005.181, 4005.181, which to 2SF is just 4000. So that's the value of A. So we can say in the form that they want, N is equal to A, which is 4000, times B, which is 0.98 to the power of T, okay, which is going to be our T there. It's going to be T here. So in this case, the T stands for the number of years. Okay, after, the T stands for the number of years. See, T is the number of years after the monitoring began. So in this case, T is equal to N minus 1. Okay, T is the number of years. T is not the term. Here, this N is the term. Okay, this N is the term. And T is basically the number of years. All right, so you have to be careful. So in this case, if we think about it, this is when T equals 1. Okay, this is when T equals 1. All right, but this is when N equals 2. T is N minus 1. All right, so that's when they say T is the number of years, it's not the same as T is the term. T is the position of the term. No, N is the position of the term. T is the number of years after monitoring began. So our N2 is equal to our T1. N equals 2 is equal to T is the same as T equals 1. That's why you have to be really careful in this question. This type of question is really confusing for a lot of students because they mix up the N with the position of the term with the number of years after. Okay, so that's where you have to be really clear on this. Very, very important. Okay, so the next part of the question says, When t equals capital T, the number of dormice on the island is equal to the number of voles on the island. Find, according to the models, the value of t, giving you answers to one decimal place. Okay, so now we're going to use this formula here, which is 2000 times 1.03 to the power of, where was our final formula? We didn't get, yeah, so we have to make the formula. So it's going to be to the power of t. Remember, this is n-1 is the same as t. So you're going to have 2000. So you have, for the dormice, the number of dormice is going to be 2000 times 1.03 to the power of capital T. And the vermin, or the voles was, what was it again? It was 4,000 times 0.98 to the power of T. So 4,000 times 0.98 to the power of T, when T equals T. Okay, so these will be equal to each other. We want to find when the number of dormice is equal to the number of voles. So I'll put this as small t for now. Okay, these are the formula for the numbers of dormice and number of voles. So when the number of dormice is the same as the number of voles, that's when t equals capital T. So we got to solve the equation 2000 times 1.03 to the power of capital T is equal to 4,000 times 0.98 to the power of capital T. So we can divide both sides by 1,000. Okay, and we can divide both sides by 2. Okay, and you'll end up here with 1.03 to the power of T is equal to 2 times 0.98 to the power of T. Okay, so we want to find the value of T. We can do this by using logarithms, but we could set it up first by dividing both sides by 0.98 to the power of T. So you have 1.03 to the power of T divided by 0.98 to the power of T equals 2. And we understand from our understanding of laws of indices that a over b all to the power of n is the same as a to the power of n over b to the power of n. So we can work with that backwards because they're both raised to the same power. I can say this is 1.03 over 0.98 all to the power of t equals 2. Okay, so let's see, we have 1.03 over 0.98. Okay, that gives us, I'll leave it like that for now. Okay, let's call it 103 over 98. 103 over 98 all to the power of t equals 2. And I want to solve this. So what I can do is I can take log to the base of 103 over 98. You can take the base of anything you want, as long as it's something feasible to you. You can't be like a negative number. If you take the log to the base of anything you want, and that will get rid of this log, so you'll have t equals log to the base of 103 over 98 of 2. You could take log to the base 10 of both sides if you wanted to. You can take, well, you don't know about Lindy, so log to the base 10 of both sides if you wanted to, but you can take log to the base of this number to which that one you want to find is raised, and that will give you the correct answer. So because we have that in our calculator, we can use it. Makes life a bit easier then. So we say log to the base of 103. So 103 over 98 of 2. And that gives you the answer, which is 13.92. So t equals 13.92. 929. It says give your answer to one decimal place. So here we just say 13.9. 13.9 is the number of the value of t. This one, the value of t. Okay. All right, that's all they want, the value of t. And they want it to one decimal place, so the answer is 13.9. Okay, so there's your answer to this question. Again, this is the type of question you have to be very, very careful of because of this whole issue of, the value of n in our formula and after how many years. And it becomes clear in this that the t here is equal to n minus 1. Okay, because you see, when t is 1, n is 2. When t is 7, n is 8. Okay, so the t is after how many years, and n is the first term is when n equals 1. Right? So you've got to be very, very careful about that. Okay, so that concludes this question number 10 from this June 2024 paper. Other questions from this paper can be found on the playlist that will be linked at the top here. Other questions from the topic of series you can find over here, and modeling with series, I'll make a special playlist for that over there. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.